Good. Hello from my side, Jochen Haerdtlein, Bosch. They're responsible basically also, again, in two roles. One is I'm head of software development for new energy products, so I mean everything beyond ICE. And the second one is that I'm chief software architect for the complete setup. So in these roles, I'm basically here. I would like to thank the colleagues from Iveco. I think it was a perfect setup for that, what I would like to put on that. So for me, it's basically clearly my home turf is the software part, and I would like to pitch a bit in how we can bring that and extend in our vehicle systems and beyond to basically gain more efficiency and more benefit out of that. So core point is basically about energy management. Then clearly we need to talk, I think that's a topic we need to ground basically in the right way. It's about the topic software-defined vehicle, which is actually less in the core about software. It's more about how we structure and how we collaborate on software. Then also the connection beyond the vehicle and also the surrounding systems, what we see, that would be the rough thread I would like to talk about. So energy management. Energy management comprises several kinds of topics. The basic principle we try to follow in that context is every joule counts, right? So while clearly there's option also in combustion engines, nevertheless there was more, especially heat, more excess available, right? But we see for pure electrical vehicles that it's getting more and more restrict, and we need to really concentrate on to exploit everything what's there. To waste any kind of heat is basically to be reduced at this context, and clearly a significant share of the overall energy is going to the powertrain, to the drivetrain. That's clearly one point. But also the second pillar is the thermal management within the vehicle, and also beyond. This is basically a second pillar we need to focus on. And especially also if we look towards, for instance, the power net, what we see for the automotive driving topics and so on. We already had in the previous talk, knowing what's ahead, basically. Yeah, so to have some kind of prediction, that is the best thing. If you compare a good driver with a very good driver, typically from efficiency perspective, a very good driver has some thought what might happen ahead and be prepared for that. Yeah, and this is basically the point what I think we can and shall bring to the system to make them much more efficient in this context. So this is the look into this vehicle energy management and also the software we put on top of that. So clearly it starts from the charging perspective, right, where we already get some kind of requirements also from legislation, right? Upcoming legislations also talk about the efficiency coming from the energy put or into the car, into the vehicle, what losses we have over there. So we talk about end-to-end efficiency in this context, right? Then clearly on the right side, we have the battery systems and so on itself, yeah, but the thermal system itself is also a pretty important topic, especially the most unpredictable point, the cabin we already had in the previous talk as well, is pretty much to be incorporated to gain most customer benefit. That's a primary thing what we have, right? So to have the comfort while we also have the efficiency in the overall system running. And there we see that this has to be steered, monitored, updated, equipped with solutions we get in software. This can be steered, this has to be there, and also has to impact a bit how we handle and how we implement our systems compared to do what we in the past. I will come to that in a second basically, right? And also, if you look at thermal management, we have some parts which have to be cooled, some parts which have to be heated, right? How to transport the energy in the right way, how to do that in the proper way. And typical system, they have some kind of lag if you can transport that. So to being early enough to switch over fast enough, not only react, but act in that context, that is in the predictive part the most important point for all of it. So knowing about profiles, storing those profiles, this also has a link, for instance, to the topic of digital twins. In that case, maybe sometimes also digital twin personalization of a driver, right? That's also one important point what we see at that context. And then also influence with that context how we lay out those systems in the best way that they act most efficient in that context. This is an important point. And we always have around that we have systems which have regulations and where we need to easily provide diagnosis and also ensure the safety in those systems, that they run properly accordingly. And our challenge as a supplier is we see, especially in that market, that this is a vastly evolving market. We see, especially with new players, a lot of new solutions come into the market. And we know that out of our combustion engine world, we need to deal with the variance we see in the market. Yeah? So to have the right abstraction at the right point, to easily plug in new solutions and adapt your solution control strategies exactly to that, what the components bring, this is exactly the point what we see as a challenge to come along. Because as said, while the combustion engine world was a bit of a closed world, new players were rarely coming in, right? We see, especially also to the markets more of the Eastern world, we see a lot of new players coming in, and to deal with that is one of the basic business challenges what we see, that this has to be addressed in the right way. Exactly, and as mentioned before, and this is a link to that, we see that the prediction is one of the most important things to gain more benefit. If you detect, react, yeah, you can gain something, but we see clear limitations. And overall, to get the right information out of the system itself, but also the surrounding systems, like being it from navigation data, like being it from temperature, whatever around, this is the big challenge to incorporate in the right way to gain most benefit out of that. And this is also a challenge what we see that's necessary to learn. Yeah. And clearly, that's always a point, how to collaborate on that level. That will be maybe the next part of my talk then. That we see we need to collaborate on solutions, on algorithms. We need also to collaborate on the data in the right way to gain the best benefit out of that. If we continue to develop here our island solutions, I think we will going to struggle and we will not gain the speed we need to bring here solutions into the market. Let's talk about software-defined vehicle. Okay, it's a pretty much buzzword pressed around, yeah. Here is our definition, I think pretty much hopefully matching to what most think about. So basically, if you have a software-defined vehicle, it's not that you ignore hardware. However, you need to enable your system that it can be changed via software, especially after you have produced it. So that's the most important point, to do that in the right way. So it can then adapt, it can then bring customer value out of the, let's say, initial state, Werkseinstellung, what you brought it basically to utilize to that. We have that also in other domains to do, like if we get our smartphone, right, we always then personalize it on the ways. That's basically the same thing we need to do and also learn on the topic of a lifespan. We had the topic about digital twin in the previous talk. Yeah, it's also about talking about aging of components, right? So, and you can adapt also your system due to that aging components. These are nodding, that's very good, right? So, though this is a topic, you can basically utilize a system much better and react on that even before it comes then to the hint towards predictive maintenance and so on. However, we've built in the past so far pretty much embedded systems which were highly optimized and integrated. So do an easy update in such systems, it's pretty much difficult. And for that, we see we need to also rethink a bit the way how we structure, how we develop our software in that context to really enable that. Especially also with a topic not only after SOP, where we can update software, but also we see during the development phase, where more and more partners collaborate on that to bring the topic on the road. And for that, that's basically how we strictly now implement basically some kind of separation into the systems, where we clearly have some kind of hardware abstraction, By the way, what we currently perceive in the market, that is clearly a trend to higher computing power, microprocessors. Nevertheless, we see that microcontrollers are pretty much interested also to have integrated solution X in one in that, because microcontroller is a much easier to control system if you talk about safety and real-timeness compared to the microprocessor units. So for that, this is a current trend, what we see, that there is an own stake in that context to really serve about that. So not all of that what we talk here is really only focusing on microprocessor. We also see a clear stake here in microcontrollers to be here available. And then we separate, basically, we have some kind of middleware solution, because we need to face the reality that if different partners collaborate and contribute to a system, they might not all work with the same standard, with the same tools and so on. And you need to consciously decide to bring that on one level, how to collaborate, how to exchange the necessary signals and data around that. So having a middleware system in place, and this can connect embedded topics in real time, but also can connect embedded signal-based topics to a service-oriented architecture in that way, to provide flexibility in that way. So it's a specific point what we see, what's required at this end to bring it forward. Then we have something what we call software fundamentals, or product application software, where we say this encapsulates that layer which is relevant for the system. It covers all safety relevant parts, it covers all security relevant parts, it covers all device encapsulation, where we basically do the transformation from electrical signals to physical signals and backwards and so on. We cover diagnosis in that topic to basically have a fundamental layer available where any kind of change in the differentiable software cannot lead to any negative impact that the system might not work anymore. Yeah? So this product application software is our stake. What we see, we need a layer where we say this we need to encapsulate, and we need to bring together all safety, diagnosis, security, critical topics into one layer, such that we can easily change the differentiable. Those we would more and more change topics on the topic. And this is also the layer we propose with our customers to collaborate on, that basically we have a layer where we say any kind of differentiated features, so which can then also come from a third party, from the customer itself. So we are pretty much open here in the collaboration. To bring that basically ahead, and also then have the solutions, like we just heard with the topic of digital twin, to connect it then basically to the outside world. So to have the right structuring is essential, otherwise you will not get it forward, especially if we talk about connected services, which do not only provide a hint to the driver, you should go to maintenance. If we have a feedback loop which steers back to the vehicle, that we directly would have a closed loop to the cloud and back, then you need to have an embedded system which cannot be affected by anything not being available, not being correct the way transmitted and so on, to be there. So this backbone is so essential to basically get it forward and running. And this, what we see, is a biggest change in setup in development, what's necessary to bring those cycles ahead. And looking at the cycles, this is not a theoretical thing. We have that running. We have that in implementation with some of our customers to really get development cycles down across their different kind of vehicle models we serve, basically, to get a faster evolution across the models, of the features across the models, before SOP, but after SOP, to basically get that running in a much more effective way. So having the right architecture and separation in place is essential to get our systems in that speed what we have running. And this is especially a topic what we see a lot of Asian customers are much ahead from that what we see from the traditional ones actually here. And for that, this collaboration is key. And collaboration means that we have built up a portal, what we call customer front end, where we can collaborate on eye level with any number of partners in that context. So we have a cloud-based system where we have separate spaces for each development partners, and each of them can immediately update software, trigger a build pipeline, gets a final solution out there, put it directly in simulation. So to have an up to live development level portal to collaborate is for us essential to bring it forward. The traditional way to do specification, agree on the requirements, hand it over, implement it, do it back to the system, this will not gain the speed we require in that world. Instead, we see that a more parallel development is essential to get speed on the road, to basically get here the collaboration running on that end. And this basically leads to the point where we then also see the topic of connected services, and clearly to pushing data from you measure in the vehicle to the cloud and do some evaluation. I would say it's pretty much state of the art. But as said, to have also the topic of a feedback loop, yeah, to use that topic out of the cloud and steer it, put it back in your system and steer it there. This is, I think, the topic where we see that there is still a lot of discussion ongoing, how that could be there. And clearly, while in the past, for us as a supplier, our main counterpart had been mainly basically the OEM. We see that this opens up more and more. We see now that we have applications which go more towards fleets, right? Because they might have not only one brand in their fleet, they might have several brands, and they would like to exploit that solutions across their fleets, right? But also, if we look at other mobility providers in this context, how we would like to provide it on that. And this, to close that loop and have it available and to think about from the actor to the cloud and backward and do the right cuts, this is exactly the point where we need to provide that in the right way to bring that forward. And this starts, and that's also linking to what my previous speakers basically told. It goes basically from using the data for the very beginning, for the design of the next generation, basically. Yeah, you would like to learn what you can do better when you design your components. Yeah, what's the layout you required. Typically, you try to basically be on the safer side, and you try to also identify where you can improve. Yeah, what for the next level at this end. But there's also a clear point where you like to have a much safer launch of your systems into the market, because sometimes if several kind of new systems play together, it's sometimes a bit difficult to have an easy way to learn already pretty early in the phase, not only for the system itself, for the validation, but also if we look about how systems are produced at this end. And then we clearly also see the topic about vehicle operation. Yeah, we have the sustainability topic we had in the way, but also the right care. Is a vehicle used in that way? How it's intended for? This is especially if we look at rental stations, right? If you're not allowed to smoke in the car, right? Then you would like to somehow monitor was there misbehavior and so on. So these right care solutions to care about that the vehicle is used in that conditions, what is basically contractually agreed, is also one topic. We have the maintenance topics, clearly predictive maintenance, right? And what we also see, especially if we look to electrical vehicles, is that the battery as a most important and most costly component of the vehicle, that there is a need to have some kind of certification. How was that treated basically through its lifetime? That you basically can do if you do a reselling, some kind of estimation. Yeah, how well shaped is that? This is clearly to be not restrict to the battery. This is the most prominent use case, but you basically can use it also for others that use some kind, get of a bit of a life pass basically of your system. How well was it treated if you basically go towards a reselling and you can somehow estimate the value what you would like to base it on. So we see this complete chain. Where is the benefit out of that, right? From the design, yeah, across the operation, maintenance, and also beyond, yeah, towards the reselling, which basically clearly links to the idea of a digital twin in this context where this data basically is represented. And the portfolio of connected services is very much increasing in that context, right? And it spans, and this is a point I would like to highlight in that context, it spans across the vehicle. We already have also connected service solutions which go towards cities, communities, where they are caring about the air quality in their topic. Maybe it's the reason I'm coming from Stuttgart. That's the main point around that, right? But this is a point where we also see growing interest, right? That it's not only restricted to the vehicle, but the vehicle is producing some exhaust, right? Reducing the air quality, and to steer the other way around is basically the topic that. Or the second point is the topic of fuel twin, digital fuel twin, to know about the quality of your fuel, to deal it in the right way. That's also one aspect. This is a topic specifically looking at battery in the cloud, where we say to have this digital representation of a battery. We have that basically in place. It's also about going towards this certification. Where in the VDE context, we have this battery passport, what is currently discussed and finalized at this end, to enable basically, if we go to the recertification of a vehicle, to know where we are. So we have use cases within the vehicle, but the vehicle spread, the use cases spread beyond the vehicle more and more. And can that, and there was also a bit of the question to the previous talk, how to steer that and how to see that ongoing. We see basically that we need, and we have that installed, an AI-based solutions, not only on the data we get to the cloud, but we also need that already in that vehicle. We have there machine learning library available, especially what we can also use in our safety critical system, as we have a way to how to predictably use machine learning, neural network based solutions within our system to get much easier to the point, because fully understanding the physics sometimes is difficult. Because we model physics, we calibrate to somehow balance that the physics is not that optimal as we modeled it. And to get on the way to basically have that here modeled within the point is also one part piece that the overall development speed increases beyond. Then my very last slide to give a bit of the outlook, and I see already the minus seconds, but I'm just around the corner, is really that so far, the vehicle is pretty selfish and thinks we are the vehicle and we need to optimize ourselves. But we see that more and more use cases go beyond, and that with maybe the opportunity we have a Bosch, that we're not only doing automotive supply, but we also are in energy systems for buildings and so on, that we see that the connects beyond that is arising more and more, right? That the vehicle basically becomes part of a bigger system. And these topics are about to arise, on the one hand, clearly on the public side, but on the others. And again, we need to prepare it the right way, where we mainly currently see that there's an impact, for instance, on the charging strategy, or also decharging at that point, if you would like to plug it into a system and use it already at the right time in your home appliance or beyond, to basically get that running and forward. So as said, vehicle is opening to the outside. We need to prepare us internally to open in the right way, that we can steer the internal vehicle energy, but we also see that the energy steering is going beyond. That's basically from my side.